So to start with today, we're going to look at just what is a solution and how can we describe a solution, and then go from there to how we actually do describe it as chemists in terms of quantities. So using measurements and units to describe a solution properly. But just before we start, I'm just going to put some potassium permanganate in each of these. Isn't it? And give them a wee stir with the stirring rod, so I'm putting my fingers on there with those. Okay, and already I've heard some qualitative descriptions. We've got a light purple, or nearly pink, and a dark purple, correct? Cool. Right, so your observation is one's a darker purple, well, they're both purple. One's a darker purple than the other would be your observation. Your inference, either because you saw me do it, or because of the colour, is that what? I put more in one than the other. And which one did I put more in? Okay, so that's great. With a purple solute, I can see very easily which one's more concentrated qualitatively. This one's got a higher concentration than this one because it's got a darker colour. The problem is this year, in your experience, you're going to work with colourless solvents and solutes, which means you can't do that. So instead what we have to do is an experiment called a titration, where we react it with one thing called a standard solution, which we've made on purpose. So we know exactly how many grams we put in. Now, if I was to describe these, and guys behind the camera, can you just tell me if I take these too far back, please? Are they still in the thing? Cool, okay. With these, you could see when I heaped it up on the spatula that there was a lot more in this. So what was different about the two amounts? I put more in, but what numbers could I use, or what units could I use to say how they were different if I had more equipment? What could I say? Scales, like you could do mass. So which one had more grams in it? The left-hand one. So we could say this has got more grams per litre. And that's why it's more concentrated, yes? Let's go back to what we've been doing with stoichiometry though. You write a balanced equation. Okay. You write a balanced equation, and actually working with grams was a bit complicated. What did the balanced equation actually tell you? Moles or amount. So what we could do is use the molar mass of potassium permanganate, which by the way is conveniently written here on the container. Always nice. And we could turn that grams per litre into moles per litre. Alright? And that's actually our more useful unit. And the way that we do it is, because the per litre is the same, whoops, something went wrong on the board. Because the per litre stays the same, to go from grams per litre to moles per litre is the same as going from grams to moles. So you're trying to find N effectively. It's the same as the N in triangle. You've got mass in the grams per litre. You want to know N in the moles per litre. So we can work it out from there. So what we find is that to go from here to here, little n equals little m over big M. We divide by the molar mass that we're given on the container, which makes it really easy. Now this mole per litre unit is more useful, because if I know the volume in these, let's say for argument's sake that's 200 millilitres, then I can go from the concentration to the number of moles, and then I can use my balanced equation, use our stoichiometry stuff again. Alright? The way that I do that is, and again guys tell me from outside the screen please. I'm in? Cool. Is we say that the concentration equals the amount over the volume. So given that I know that if I knew my mass and I knew my volume, then I go number of grams per litre divided by molar mass, give me that, and then I can confirm the number of moles by multiplying these two. Alright, so I've got another triangle to learn. C equals N over V. Alright, and this will become really useful. So you'll see in the next bit, if you won't on this video, how we do the stoichiometry bit of solution, which is pretty much the same as what we've already done with solids and with other reactions. Alright. So, just to rewind. With a coloured solution, we can tell very easily which one's got more solid dissolved in it by its colour. We can just look at it. Problem is that we usually work with colourless solutions. Therefore, we have to have another way to do it. So what we do is we make a solution that we know the concentration of, because we've put a certain number of grams into a certain number of litres. Then we can react it with our unknown, look for, and one thing I didn't cover, we can look for a colour change with an indicator, and we will see how many moles have reacted, use our balanced equation to find our number of moles. If we know what volume we used, we can find the concentration. And the last thing I wanted to cover here was, if I'm asked the answer in grams per litre, but I've got it in moles per litre, to go back the other way. If this was divided by molar mass, guess what we do here? Times by molar mass. Cool. Alright. So that's an overview of solutions. So I'm not doing any calculations yet. That comes later.